going to finish up dimensional analysis today, so I want to get started and go ahead and do that with you. These are your notes that we're going to start on, and I believe you guys should already have this much done. These are your notes that I used from last class period. While you're getting all that out, don't forget to get a calculator out as well. A couple of little business notes I want to discuss real quickly, just in case I forget at the end of class. Let's go ahead and talk now. First of all, you have your first exam not this Wednesday, but the next Wednesday. So it really is like having it a week from today, because Monday we are out for Labor Day. And so you have one class period left before your exam. So we have class Wednesday. Wednesday, you need to make sure that you have both the day 3-4 notes and the day 4 notes. I believe on Blackboard that's how they're titled. There's a notes that say day 3-4, and then there's a note that says day 4. You need to have all that printed out. It's only 4 pages, but it's just divided up that way. So make sure that you've got all of those notes printed out and ready to go. On Wednesday, we will finish up everything you'll need for your first exam. First exam, like I said, is next Wednesday, and our exams are going to be held in Snell Hall 1108. It is downstairs. It's the large room that is across from the computer labs. It's a very large room. It's like twice this wide. It's a really large room with tables, so there's a lot of room in the room, which is nice for a test. So that's where we will be, and that's a week from this Wednesday for your first exam. This Wednesday, you do have an assignment due. Anybody want to tell us what that is? The extra credit. And the extra credit, there's information all over Blackboard about that. The extra credit can be found under, I believe it's the extra practice worksheets. The extra credit can be found there. It's a printed piece of paper that you are going to turn in to me on Wednesday. I will post the answer key after our class Wednesday evening, and you can then make sure you did it right. My suggestion would be take a picture of it before you turn it in. That way you have what you did to see if you got it right or not. You will not get it back before your exam on Wednesday. So you'll want to know if you did it correctly before then. Question?
Do we need a Scantron for the test?
No, I will provide everything you need. You need a calculator and a pencil. And that's the day you have to have your non-graphing calculator. You have to have it. You have to have a non-graphing, no cell phone. Also, just so you know right now, no smart watches will be allowed in the test. Don't even wear them would be best, because I will make you take them off. So it would be best to not wear your fancy watch that day, because you will not be allowed in the test room with those watches. So, questions on that? Put everything up, please. Phones all the way up, please. Okay? So any question about the extra credit? Any question about the test? All right. Sapling homework. I have not looked specifically at your class, but I have looked at all the grades for both classes, and it looks like most of you have, a lot of you, I won't say most because I don't know for sure if it's you all or who, but a lot of people have been on Sapling and have worked on Sapling. Good job. That's very good. It looks like you guys have been on it. I haven't had but maybe 1 or 2 questions, and it looks like those have gotten themselves kind of answered without me needing to look at it. If you do end up calling Sapling or sending them an email, I would kind of like to know, just so I know that there's been a problem. Overall, Sapling is a very, very easy to use program, though, and so I'm not expecting a lot of problems, so that's why if I do have problems, I'd like to know about it. So any questions on that? If you, by chance, were not here on Wednesday of last week, you probably will want to stop by and see me quickly after class to make sure that you are caught up, because this is going to be a little overwhelming today if you haven't watched the videos, and I'm hoping you took the time to read everything. All right, we do need to sign in today. Just remember, put your initials in the second column. Make sure that you put your initials. Please don't use red. Use another, or green. Don't use red or green. If you have added the class since you came to class, or I mean since this was printed rather, then put your name at the back. There's empty spaces back here. So I'm hoping that doesn't fit anybody, but it may. So any questions? All right, let's get started then. We did all of these, so I'm assuming there are no questions on these. We're going to actually start on this next problem. And one of the biggest problems that I've mentioned to you that students have is they don't know what is the given and what's the conversion factor. They struggle with figuring out what is the given and what's the conversion factor. Tell me here in this problem, what is the conversion factor, or what is a conversion factor? Can you find it? 250 milligrams per tablet. When I ask you what the conversion factor is, that's exactly right. 250 milligrams per tablet. 250 milligrams per tablet. That is a conversion factor, which means then what's the given? 1.25 grams. So I want to just be quiet for a minute and let you try this. Try this problem. What's my next step? So I'm converting grams to, and you can either do that with knowing 1,000 milligrams in a gram, or you can, over on the side of your paper, write down what? Say it. Come on. Kilo, hecto, deca, base, deci, centi, milli, space, micro, space, nano. Good job, guys. You are more live than you were last week. Good. So you've got that. That's very good. So 10 to the third milligrams. And then what? What goes on top next? One tablet. And then what? 250 milligrams. Good job. Sounds like you guys have been studying. All right, run your numbers, and how many significant digits should we have in our final answer? 2. Where? Where does that come from? 250. This has only 2. Does this count? No. Does this count? For 3, and so the answer can only have 2. What's my final answer? 5.0 tablets. Good. 5.0 tablets. Yes or no? Talk to me. Question? Any questions on it? Okay, the next problem contains something that's not needed. Can you find what is not needed in this next problem? Good, good, very good. Let me ask this question, and you'll have to speak out to tell me, because it's going to be kind of you'll have to explain it better. Tell me why you don't need 58 pounds, and let me say why I'm asking that. Typically in a medical situation, you need to know the mass of the body that's getting the medicine. Am I correct? And then your knowledge says you need this many milligrams or whatever of drug per kilogram of body weight. So you have to do all this math and figure that out. Why don't you need the mass of the child in this problem? Say that again? No, that's not why.
It's already been prescribed.
That's why. Somebody else already figured out you needed what? 240 milligrams of acetaminophen. In other words, 240 milligrams is the dose needed for a 58-pound child. Someone else did that back work for you. Now, most of the time you have to know that. My doctor, he will ask, if he doesn't have the chart right there in front of him, he will ask, how much does she weigh? Before he prescribes the medicine. He will always ask that. Why? Because he has to know what she weighs in order to know how much medicine to give the kid. That's a typical thing to need to know, but because this has been done for you, this doesn't matter now. Okay? So that's not important. Leave it out. Now what's the given? 240 milligrams. So looks like some of you have done it. The rest of you, get going. Figure it out. I want to know how many milliliters of children's Tylenol is needed. So run the numbers. What's my next step? What goes on top? One teaspoon. I heard 160, but I didn't know where you meant to put that. So I'm assuming you meant to put that on the bottom. Is that right? So 160 milligrams goes on bottom. That cancels. Now what goes on top?
5 milliliters.
Good. And what goes on bottom? 1 teaspoon. Teaspoons cancel. Run your numbers. Significant figures, how many do you have in the given? 2, 3, and that doesn't count. There are exactly 5 milliliters in a teaspoon. So that does not count. That is exact. That is exact. So what's the final answer? 7.5 milliliters. Good. Making sense or not?
How is 60 milligrams per teaspoon? How is that?
Based on the fact that, and this is something you probably don't know or you just didn't think about, children's Tylenol is a suspension, meaning it has to be shaken. So it's supposed to be 160 milligrams, but it's a measured number, which means that you could take one whole bottle that's 6 ounces and test it 5 times, 10 times, and that's the average. So that's why. It's measured. Okay? Other questions? All right. I'm going to skip the top one. This one is something you should be able to do on your own with the information we've already given. One thing I do want to point out on this one is this fluid ounces or dry weight? Say it again. Dry weight. So does 16 ounces in a pound help you here? Yes. Does the ounce and milliliter scenario, is that where you want to go? No. So make sure you understand the difference. This is talking about mass. This is the mass. And there's several ways you could do this. You could do it with your pounds to kilograms. Then there's tons of ways you could do this one. I say tons. There's 2 or 3 ways immediately that I know to do this. The answer key, I'm not sure how many ways I did it on the answer key, but the answer should be very similar each time. This problem, I want to find the conversion factor. What's the conversion factor, other than what's in the parentheses, obviously? What's the conversion factor in the problem? Good job. 0.75 teaspoons per dose. You guys are really doing well seeing those this fast. That's really good. So 0.75 teaspoons per dose. Now, there is another potential conversion factor, but it could also be used as the given. And I will say that's unusual. Typo here. This should be in a bottle, not on the bottle. Many times, the given is near the question. Many times the given, the starting point, is actually near the question that's being asked. And that is true here. That is true here. Anybody know what it is? What it could be? 1 bottle. 1 bottle could be the given, because read the question. Get rid of all the junk and just simply tell me the question. How many doses are in the bottle? So 1 bottle is the given. But quickly we see 1 bottle is 6 ounces. So what can you start with? 6 ounces. So you could say 6 ounces is a bottle as a conversion factor and start with 1 bottle, or you can just simply say 6 ounces. And that's fine. Either way is fine to do that. So let's start with the 6 ounces. And I want you to try it. Let me give you time to try it. Sheet. Does anybody miss the sign-in sheet? There's a lot of blanks on it. What did you do next? Where did you put 1 cup? So 1 cup, then what? 8 ounces. That got rid of ounces. 1 pint is 2 cups. This is where some of you are like, I don't know what to do at this point. 1 pint is 2 cups. Why are they going this route? So they can get where? To milliliters. Now, there is a conversion, I believe, that gives you ounces and milliliters. Am I right? Could you use that one? Yes, and it makes it shorter. I haven't memorized that, so I'm not going to use that one. But you may, definitely. If you've got that one in your head, do it. My reason I don't choose to memorize all those, because I can solve the dimensional analysis problem. I'm really trying to focus on you guys. It's okay, I'll get it in a minute. I'm really trying to focus on you guys knowing how to do dimensional analysis. And that's why I have suggested that you limit your number that you memorize. Because you have to remember, you're not going to have your sheet in front of you when you're taking your test. So it's better to know how to do it and limit the number you memorize if you have limited resources. Okay? If you feel like your hard drive's full, then limit it. Okay? What's next? Doing it the long way. What's next? 1 quart is 2 pints. Pints cancel, then what? 946 milliliters in 1 quart. Quarts cancel. Now what? So where does the 1 teaspoon go? On top. So 1 teaspoon on top, 5 milliliters on bottom. And 1 dose is 0.75 teaspoons. So finally we are in doses. Does that make sense? Some of you are not writing. I'm hoping that means you've already done it. What do you get? Go ahead. 47. Now, why did I stop at 47? Significant figures. How many significant figures are here? 3. That is exact. There's exactly 8 ounces a cup. Exact, exact. 3, exact, 2. That's where the 2 came from. Real world scenario, not dealing with medicine, although this is somewhat important. Tell me where something like this might be useful. This process, and I'm going to throw in money. There's money involved. Let's say that it's amount of money per dose. How much does 1 dose of medicine cost? Because I could do that. I could have thrown that in. Where might money and big containers, I'm going to give you the hint of food, where might that be useful? Tell me a scenario where that might be useful to be able to calculate. If you ran a restaurant. Think about that for a minute. If you ran a restaurant or a catering business, is it important to be able to calculate how much you're actually spending per meal to know what to charge? And sometimes, just like, for instance, one of the things in a kitchen that you don't think much about, sugar. You got sugar. You don't think about, what did that sugar cost me? But prices of sugar can vary greatly depending on whether you buy Domino's sugar, whether you buy generic sugar, whether you go to Aldi to get your sugar, whether you go to Kroger to get your sugar. There's all kinds of ways that that varies. Someone who really knows what's in their product, money-wise, they know what's going on here. Does that make sense? You're seeing that? I'm trying to get you to see the application in the real world, and that's one of them. All right, the next three problems all have a similar theme, and that is that you're looking for units that have something to the power. This one's cubic meters, this is meters squared, and this is gallons. So instead of saying it's something to the power, I could say in these two scenarios, it's volume that we're trying to find. But the units that we have to begin with are not volume looking, are they? Are they length? What's the formula mathematically for volume? Length times width times height? And so this is, somehow we have to figure out, if we know the length times width times height, how do we get volume in like liquid volume? So in order to do that, let me show you something. Now you don't have to write this down. Let me just show you something. You're going to think I'm being goofy. So, but just all you have to do here is say agree or disagree. Agree? This is not super tricky, okay? Agree. Agree or disagree? Disagree. In order to make this side equal to this side, what do I have to do? Square it also. Now we say agree, right? Okay. Agree. Disagree. Disagree. Good job. You should say, I disagree with that. In order to make it agreeable, what do you have to do? Square 2.54. Now, some folks still may say, well, I still disagree with that. Well, this is agree. You should agree with this. Why do they not understand it? Because they haven't thought about it too much, and they didn't realize 1 squared is still 1. 1 squared is still 1. What does this mean? All right, take your hand out and look at your hand for a minute. This pinky, pretty much everybody's pinky, is about 1 centimeter wide by 1 centimeter. In other words, if you were to cut your pinky off at the right below your nail, that's about a cubic centimeter. Okay? But let's just deal with the centimeter, one dimension right now. So that's a centimeter. Now bend your pinky, and from this knuckle to this knuckle, that's about an inch. You can check me on this later with a ruler. But that's about an inch, okay? So this is about an inch, and this is about a centimeter. So 1 inch by 1 inch, I don't know if I can do that or not. 1 inch by 1 inch, there we go. 1 inch by 1 inch is about like that, right? So I had a little, just a flat square, 1 inch by 1 inch. That's the same as 2.54 centimeters by 2.54 centimeters. You with me? Okay, in other words, 2.54 of those. Follow? Okay, so this is a conversion factor now. And this can be used as a conversion factor. What about this? Is that true? No. You should be saying no. That is not true. Is that true? Yes. This is one you're supposed to memorize that I haven't really mentioned much about. I just said memorize it. Now let's talk a little more about it. Go back to that pinky. Cut it off. Right there below the nail, cut that pinky off, and you have a 1 centimeter by 1 centimeter by 1 centimeter. You follow me? Now hollow it out, fill it up with water, and guess what that volume is? It's been 1 centimeter cubed the whole time, but now what could you call it? 1 milliliter. 1 milliliter. Now, the medical world likes to give their own names to things. What do they call that? 1 cc. Now, to explain to you some of my own density and ignorance sometimes, when we first started farming, I grew up on a farm, but we didn't buy our own farm until about 8 or 9 years ago. And when I first started having to give the goats medicine and all this stuff, the vet would say, give them so many cc's. And I knew it was the same thing as a milliliter, but I hadn't really sat down and thought about, why do they call it cc? I mean, she would say that, and then I'd say milliliters. I would like repeat it and say it in my own language. And then one day, you know, the light bulb went on. CC stood for cubic centimeter, you know, the first letter. And I'm like, oh, that's why they use that. Now, why didn't I know that? I don't know why I didn't know that, but it just never had really hit me. That's why it's called CC. I don't know why they call it that, but that's what it is. All of those, if you've ever seen, and every time this morning I said the same thing, and I've been home, but I didn't go to the barn, but I should have brought back a syringe. I think this every semester. I have a 3 milliliter syringe that is about the diameter of my pinky. And if you saw that 3 milliliter syringe, that 1 milliliter, which is what I'm talking about, the end of my pinky, that's about what it looks like in that syringe. And so then this kind of makes more sense to you, and you can picture that. Overall, though, we don't think milliliters that well. Why not? Because it's a metric unit we didn't grow up using. We grew up, now you guys more than me. You do know what 1 liter and 2 liter looks like. You do know that because you grew up with 2 liter bottles. That's something you have been exposed to. But for me, quarts and gallons and pints and cups, that's how I grew up. So this milliliter is a little more foreign for me, but it does make sense once you get the hang of it. What's the benefit of this conversion factor? The huge benefit is this is a length measurement. This is more of a liquid. So this is like a length times width times height volume. This is a liquid volume. The good thing that this allows you to do is if you have a tank, for instance, a fish tank or a swimming pool, let's say that you buy a swimming pool on clearance and next summer you go to fill that swimming pool up and somebody yells at you because the water bill, they think you've let the toilet run or something for like 2 months, and you get this $500 water bill and nobody knows why. And then finally it dawns on you, oh, the swimming pool, we filled up the swimming pool. Well, how many gallons did it hold? Well, I don't know. Can you figure it out? You're still saying, no, I couldn't. You should be able to figure it out. You should be able to figure out the volume, and then once you know the volume, maybe you get the volume in inches cubed or feet cubed. Can you then convert feet cubed to inches cubed? Keep going. Inches cubed to centimeter cubed to milliliters, milliliters to quarts probably, if you're trying to figure out your water bill, because that's going to be in gallons, and then quarts to gallons. Let's do some. Let's do some. Let's do the first one, just the square meters first. First thing you do is going to be what? You're going to simply find the area. And what is this unit? I've found out some people don't know what that is. Inches. That means inches. So what is this? 54 inches squared. So 54 inches squared is your given now. 54 inches squared is your given. I'm trying to get inches squared into meters squared, so what am I going to do? Inches squared to centimeters squared. What is the just normal conversion between centimeters and inches? What goes on top? Over 1 inch. Now that's just the normal conversion. But to make it work, what do? Do I square everything? Yes. 2.54 squared, centimeters squared, and for the sake of making sure we all understand it, it probably would not be a bad idea to go ahead and square the 1. But again, 1 squared is 1. So inches squared cancel. You are in centimeters squared. Then we take centimeters squared to what? Meters. This is where some people get pretty confused because you don't know how to do centimeters squared and meters squared because then there's powers to powers. Forget that for just a minute and just first tell me the relationship between centimeters and meters. Tell me that relationship first. So what goes on top? 1 meter, what goes on bottom? 10 to the second centimeter. Yes or no? Then what do we do to all of this? Square it. So that means 10 squared squared, centimeters squared. Our centimeters squared cancel and we are in meters squared. How do you take care of a power to a power? You multiply. Power raised to power, multiply. I don't mean it. If you need to write more words than I wrote, please write more words than I wrote. But a power raised to a power is multiplied. You multiply the powers when a power is raised to a power. Now here, whether you multiplied it or added it, you're still going to get what? 4. Okay? I'll show this to you again on another one so that you definitely see this. I would suggest that you go ahead and put 10 to the 4th there just so that you understand later that's what you're doing. Now run your numbers. You either have a squared key on your calculator or you have a y to the x key. Either one is fine. What do you get on your calculator? Meters squared. I went ahead and circled that, but I do have to go and talk to you about significant digits. Let's talk about significant digits. Do I use calculated numbers to get significant digits? No. I'll answer my own question. No. You go back to original numbers. How many significant digits are in 6.0? 2. How many are 9.0? 2. So that takes care of this, and then all these are exact, aren't they? So how many should be my final answer? 2. Now, I circled it before I talked about significant digits. How many significant digits are here? 2. Only 2. That is 2 significant digits. Now, I think some of you did not get this answer. Clear it all out, and let's do it again. 54 times 2.54. Use your squared key. Hit square, x squared. Divided by 10, y to the x4, or the caret key 4, equals. Did you get it? Everybody get it that time? Okay, I'm going to sit back for a minute and let you try this one. Start on this one. And do me a favor, do yourself a favor. Do not use your calculator for the first part. What's 8 times 10? 80. What's 8 times 12? 96. So 80 times 12 would be 960. Okay. So start with 960 meters cubed. Start with 900, and I told you wrong, that's feet cubed, sorry. Woo! Feet cubed. Don't put meter cubed. Feet cubed. Feet cubed. You're trying to find meters cubed. What is my next step? What goes on top? Tell me everything this time. 12 cubed, inches cubed over 1 foot cubed. Just set it there. What's next then? 2.54 Good. Good. Now, this is the part that people get stuck on, part of the part that people get stuck on. Right now, stop cubing and just simply tell me what is the relationship between centimeters and meters. 10 squared centimeters in 1 meter. So now if we go back and cube all of this, that's what it looks like. 10 squared cubed, centimeters cubed. Centimeter cubed cancel, and now you're in meters cubed. To prove to you what you should do this on your calculator. What is, actually, I'll let you do the whole thing on your calculator. Take 10 and then hit your squared button. Everybody has a squared button on their calculator. They should. What do you get? 100? Now hit y to the x 3 equals. And count the zeros. How many zeros? 6 zeros. So what do you do with the power raised to a power? Multiply them. So what I would strongly encourage you to do, rather than doing what we just did there on the calculator, just get rid of this and call it 10 to the 6th, so that when you plug it in your calculator, you don't have all the other to do, because that will get confusing. So do this ahead of time. What do you get on your calculator for the answer? Good. Significant figures, go back to original numbers. So how many should be in our final answer? So what's my final answer? 27 meters cubed. Good. Cubic volume of a room like that is actually used for air circulation systems and filters, filtration systems. Some of you may have no knowledge or some knowledge of HVAC people. That means heating, ventilation, air conditioning folks. They have to know this type thing. They have to know and understand a unit can have a maximum volume of da-da-da-da-da. So units are sized based on house size. And it's not just square footage, but it's also if a house has 12-foot ceilings versus 8-foot ceilings, or 10-foot ceilings versus 8-foot ceilings, is that going to make a difference? Yes. And so this is one of those things in the real world that's useful. This one is from the farm. It's very, very similar to the same scenario that I gave you with the swimming pool, except I did something to make it harder. What did I do that makes it harder? Not hard, but longer. I gave every one of those in a different unit. So what do you have to do to start with? Get them in the same unit. Then once you get them in the same unit, what will you do? Multiply them, and then start the rest of it with the cubing and all that. Which unit do you think it would be best to put them in? Some of you are saying inches. I would say centimeters. In the end, it doesn't matter. It doesn't matter. Why did I pick centimeters to start with? Anybody know? Because centimeter times centimeter times centimeter is a centimeter cubed, which is the same thing as a milliliter. Okay? Try it real quick. 34.25 inches. Convert that to centimeters. Then you're going to, you already have the 47.5 centimeters. So that's one that you're already going to use. And then do your 2.25 feet and get that to centimeters. And then you're going to multiply all these together to get this long number that you can't round. That's going to be centimeter cubed. Try it. These are the numbers that you should get when you convert them into centimeters. When you multiply those together, you get 283390.5623. Anyone get that? Okay, good. Don't round it. If you round that number, all the rest of your problem is going to be off. So you cannot round until the end. The good thing is you did the calculation, so it's on your calculator, and you don't have to add it to the calculator. It's there. So don't delete your calculator. Now, what do we do? What's the next step? 1 milliliter is 1 centimeter cubed. Centimeter cubes cancel. What goes on top? 1 quart. Keep going. And 1 gallon, 4 quarts. Good job. Calculator gives you 74.89179, something like that. Yes? It should, yes. What happened with you is, if you started with inches, you have this one as it is. You converted this one to inches. You stopped here for that. And then you've got inches cubed, and then 2.54 cubed, centimeter cubed over 1 inch cubed, and then everything else is the same. And that's fine.
When you were converting inches to centimeters, why did you not worry about significant figures?
Because your significant figures are going to be based on your given numbers that are given at the very beginning of the problem. You don't use this number for significant figures. You don't use these for significant figures because we shouldn't round until the very, very end. And this is exact, this is exact, this is exact.
I was just thinking like 34.25 is for significant.
It is,
86,
which we're going to worry about in a minute.
but we don't worry
We do not stop here because this whole process is multiplication or division. If we were throwing in addition subtraction in here, then we would have to look at significant figures before we moved on, but not now. All of this is multiplication division. So we go back to original numbers. This is 4 significant digits. This is how many? 3, and this is 3. These are all exact. This is exact. What's this? 3, and this is exact. So my final answer should be what? 74.9. Keep going. Gallons. Gallons. Yes or no? It seems like you guys are understanding it. I'm hoping that you are as well as you seem to be. All right, we're going to stop for dimensional analysis for just a moment, and we're going to do simple math equations. On your conversion factor sheet of things you need to know, add these 2 mathematical equations. Kelvin equal degree Celsius plus 273, and degree Fahrenheit equals degree Celsius times 1.8 plus 32. Real quickly about Kelvin, let's talk about Kelvin. Kelvin is the absolute temperature scale. If you've ever heard of absolute zero is 0 Kelvin. That supposedly is as cold as you can get. Or we can't get that cold, we'd be dead. But that's as cold as it can get, is absolute 0. That's 0 Kelvin, which would be negative 273 degrees Celsius. Okay? For now, Kelvin is just something I'm asking you to learn how to do. In several weeks or a month and a half, 2 months, you will actually be doing problems that have to be converted into Kelvin, and that's why I'm teaching it now. The Fahrenheit and Celsius is something that I think you need to know how to do. I think it's important to be able to go between the two. Now, I'm not very good at 100% indicating if I have an international student or not, unless it's like an obvious scenario. But I don't know if any of you are international students or not. But last semester I had a Saudi Arabian student, and he knew metric system, and he knew Celsius because that was his world. We don't. Celsius for us means nothing. If I say it's 90 degrees Fahrenheit outside, you know what that means. If I say it's 72, you know what that means. But if I said it's 28 Celsius, that means nothing. So we understand Fahrenheit, others understand Celsius. I think it's good to know the difference. Many of your science entries that you're going to read are going to be in degrees Celsius, and that's why we're learning this. As far as significant figures are concerned, this is the one place that I get lackadaisical or just say don't worry about it, which is unusual for me to say that. This is that case. You do not have to use significant figures with temperature conversions. I will tell you how to round it. You are thinking, somebody is thinking, why? Why didn't she care on this and she's been so picky on others? Well, here's why. This is a constant, this is a constant, this is a constant. And this is addition, this is division or multiplication, this is addition. There are so many things in that that you have to say, does it matter or does it not matter? Do I use this rule? Do I not use this rule? I want you just to know how to calculate between Celsius and Fahrenheit. So I don't want you to focus on the significant figures and get confused about that. That's why I say don't worry about it. So let's not worry about it. I'm going to tell you on this particular problem, round to whole number. Last thing before I leave, just to show you the math here, something I didn't mention. There's no degree symbol for Kelvin, and there are no negative temperatures. It's absolute. Absolute. All right, simple algebra. 70 degrees Fahrenheit equals degrees Celsius times 1.8 plus 32. Now, where did I get that? What did I do? I just simply plugged in 70 degrees Fahrenheit for this F. Everybody follow me? For those of you that are squinting back in the back, why don't you sit up front tomorrow or next day? So 70 degrees Fahrenheit equals degrees Celsius times 1.8 plus 32. Now let's talk math for a minute. What do we do first? Subtract. For those of you that think I'm being silly to explain this, there are people here who don't know this. So this is 38 degrees Fahrenheit equal degrees Celsius times 1.8. Now what do? Divide both sides by 1.8 and do the math. Degrees Celsius equals what? 21 degrees Celsius. It actually works out to be 21.11111, but I said round to the nearest whole number. Question on this. Kelvin is degrees Celsius plus 273, so that's 21 plus 273, 294 Kelvin. Yes? All right, you do the next one. .37 degrees Celsius is what? .310 Kelvin. Do I put a decimal after this? If I'm rounding it to the nearest whole number, do I put a decimal after it? Yes. Why? Even though I said I'm not, quote, counting significant digits, if I'm telling you to round to the nearest whole number, I'm saying the nearest whole number has to be significant. So if I didn't put the decimal, would that 0 be significant? No. Yes or no? Does that make sense? So you put the decimal. You put the decimal after a 0, if it is significant. All right, on this problem, I'm going to tell you, on this problem, I'm going to change my rule, and I'm going to say round this one to 10th. And there's a reason for that. So do the math and round that one to the nearest 10th. What is that? What is that? Body temperature. 98.6 degrees Fahrenheit. Question on those? Any questions? I flipped the page. I saw a lot of scrambling. Did you get the last thing here? Density. Density is a mathematical formula. It stands for mass per unit volume. Easy way of saying it is simply mass divided by volume. The units are commonly gram per milliliter or gram per cc. You need to add the formula for density to your list of things you need to know. So you need to put D equals M over V, or density equals mass divided by volume. You need to know how to calculate density. So add that to your things to know. Also add to your things to know the density of water, which is 1 gram per milliliter. Now, that is at 4 degrees Celsius. I'm not going to worry about the temperature. We are going to say the density of water is 1 gram per milliliter. That's what we are going to call it. The density of water is 1 gram per milliliter. So I'm going to go back to my pinky. My pinky, if I cut it off there, hollowed it out, and that's a little 1 centimeter cubed box, and if I fill it with water, what's the volume? Wouldn't matter what I filled it with. What's the volume? If it's 1 centimeter cubed, what's the volume? 1 milliliter. Now, if it is water, what is the mass? 1 gram. Let's get this in our head. Are we all with me on this is 1 centimeter cubed? If it's full of water, that's 1 milliliter of water. What is the mass of 1 milliliter of water? 1 gram. Why? Because the density of water is 1 gram per 1 milliliter. If it were another substance, would that be the mass? No. If it were corn syrup, would that be the mass? Is corn syrup more dense or less dense than water? More dense. More dense. Think of really thick syrup, really hard to pour. That's more dense. That means that it would have a greater mass because its density is different. So density relates mass to volume and volume to mass. That's what density does. The first problem is simply a density calculation. That's all you have to do is calculate density. There is a special thing here that I'm having you do, though, and it has a special name for finding the volume. So the first thing I'm going to do is I'm going to write down density equals Mass divided by volume. What's the mass? 11.7 grams. Now, keep reading and see if you can figure out how to get the volume. What do we do to get the volume? Subtract what? 20.7 milliliters from 26.1 milliliters. So, why do we do that? Because 26.1 milliliters is the final volume. 20.7 milliliters is the initial volume. What is 5.4 milliliters? The volume of the salt. Does anyone know what this method is called? Say it. Displacement. Typically, we call it the water displacement method, but why didn't I use water in this scenario? Because it would have dissolved the salt. So we use something that wouldn't dissolve the salt. For those of you that are still kind of like, what? Let's go a route for the exercise science majors for a minute. In exercise science, there is a tank down in Preston Center that they can calculate. They use it to calculate the volume of a person, which then helps them figure out body fat. Does anybody back there know what I'm talking about? An exercise science major? Anybody know this? Okay. So the tank works on exactly the same principle. I have done this before. Back when I was in college, I went to the tank. I went in the tank. So what happens is you are in a swimsuit and you get into the tank, try to get all the air out of your lungs. They know the volume in the tank to begin with. You get in and you're strapped, I think, if I remember correctly, to a seat, and they lower you into the tank, and what happens to the volume in the tank? The same thing that happens to the volume in your bathtub. It rises. So what's the difference? The volume of you. The volume of you is the difference. Then if they know your mass and they know your volume, what can they calculate about you? Your density. And if they have a bone density test, and do you see what I'm doing? So you can find out a lot about a person just by knowing their mass and their volume. Then you can calculate muscle mass because you can kind of test muscles. Then you get an idea of how much fat that the person has. And that is something that can be done. So let's plug this in and do the math. 5.4 milliliters. What is the final answer using proper significant digits? 2.2. Now, what is my unit? Grams per milliliter. Do I have to keep both units? Yes. Hold on just a second. Now, something I didn't talk about, I said use significant figures, but I didn't talk about the way to do significant figures, so let's go backwards. Is the rule for subtraction different than multiplication division? Significant figures, is the rule different? Yes, the rule is different. I didn't even talk about it here, but it worked out well. Because, is this precise to the tenths? Is this precise to the tenths? That means my answer should be precise to the tenths. So this is a correct answer for this calculation. Then when I plug it in here, now I look at total significant figures, which is how many? 2, and this has 3, so my final answer should only have 2. Go ahead. You don't typically use calculated numbers, but in the case where you did the significant digits will make a difference, then you do have to use them. Back there, you're right, because the whole calculation was all multiplication division. It's a very good question. The reason we use it here is because we are following the rule properly. Back there, the rule the whole time was multiplication division rule. You're not getting it. When we did not worry about it, it's because we multiplied 2 numbers or we multiplied 3 numbers. That rule is the same rule we use in dimensional analysis, because what do we do in dimensional analysis? Multiply or divide. That's why we didn't stop like we're doing here. The reason we have to stop right here is because this rule of subtraction is different. It's a different, totally different rule. So I have to follow the rules for subtraction here. And the rule for subtraction deals with precision. So this is precise to the tenths. Now this number, it is a calculated number, but we can't base it on these because I had to be to the right precision. And then that becomes 2. That's the only time typically you're going to see that, where you have to use both rules in the same problem, is when you do a density calculation. And that's a special one where I even make you find the volume itself. I agree, it's confusing. What makes density useful? What do you think that I like about density? Let me give you this helper. I love dimensional analysis. So why do I like density? What's special about density? Not just this density, any density. That's exactly why I like it. She's got it exactly right. How is this a conversion factor? What does it have? What have I said to look for when you have a conversion factor? 2 units. Does this number have 2 units? And you know what's really amazing about this number? About density itself? All of your other conversion factors up until this point have been a length to a length, or a volume to a volume, or a mass to a mass. Think about that sheet. That sheet is quarts to gallons, or milliliters to quarts. That's volume, 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 volume. Pounds to grams, that's mass to mass. Or inches to meters, or whatever, centimeters, that's length to length again. But density gives you what? What kind of units does it have? It has a mass unit, and it has there's nothing else like it at this point that you've had. So it allows us, if we know the volume of a room or volume of something, can we also figure out the mass if we know its density? It's huge as a conversion factor. This problem is a very simple problem. I want you to come back later and do this problem, but don't do algebra. I want you to come back and make sure you do this with dimensional analysis. I want to go on and do a longer problem. So let us do this problem together. What is the given in this problem? .2 cups. I want you to study that for a minute and see if you can tell me what to do. Anyone have any ideas? I heard you go from. Well, eventually we are going to try to change it to pounds, yes. But how do we get there? Cups to pints, pints to quarts, quarts to milliliters, quarts to milliliters. Now, why do you go quarts to milliliters? Because density is in what? Gram per milliliter. So once you get to milliliters, can you use density as a conversion factor to get grams? Yes, and then grams to pounds. That's exactly right. So let's do it. What goes on top? 1 pint, 2 cups on bottom, 2 pints on bottom, 1 quart on top. Good. What goes on bottom? 1 quart. Good. Now, if I had this is when I wish I had a bell. I'd go ding, 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 ding. Why? Density. This is where you plug in density. If you understand density gets you from the volume to a mass or mass to a volume, you realize how huge that is at this point. So you immediately find density, and that's 2.7 grams per 1 milliliter. That is density. Now I am in mass. How do I get to pounds? This is, you can do it with your pounds kilogram, or I'm going to use mine, which is 454 grams in 1 pound, and boom, I'm done. Yes or no? Plug in your numbers. What do you get on your calculator? 28.411, then some other stuff. Did anybody not get that on your calculator? Because I want to strongly, strongly, strongly encourage you Wednesday to have everything you need for class. Some of you are just writing it as I write it. That's not helping you. You've got to do this. You've got to be thinking ahead of time, not waiting on me. And when you don't have your calculators, that's hard to do. Significant digits, will density count? Yes. Why? It is a calculated number. Mass is calculated. Volume is calculated. It's a rounded number. It's going to count. So 20.2 has 3, doesn't count, 3, 2, 3. My final answer is what? 28 pounds. 28 pounds. Yes or no? See a frown back in the back. Question? This is exact because if you look on your conversion factor sheet, it's on the exact side. It's on the left. So this does not count. This does not count. This does. It's on the right side. This always counts. Density will always count because it's a calculated measured number. And then this is on that not exact side. And the given counts unless it tells you exact. Like if it had said exactly 20.2 cups, it would not have counted. You go with least. Least total number of significant digits, but not precision. Count the total significant figures and you go with the least. Doesn't matter about the decimal point, though.
So density is not exact.
Density is not exact, so it will count. That's correct. Density is not exact. Tell me the difference. There's more than one, but they're minor. What are the differences between this problem and this problem? Density is still going to count for significant figures. Not about significant figures. Just in general, tell me, give me a sentence that says this problem is basically the blank of this problem. One word will fit in that sentence. This problem is basically the blank of this problem. Opposite. Now somebody's seeing what I'm talking about. Look what you start off with in this problem. Pounds. But you're trying to get to, here we started in Cups took it to pints and then got pounds. I'm not going to do this one. You need to do this one on your own later. I want you to do this later on your own. With the answer keys, they're all on Blackboard. So you do this one later on your own and check yourself. Now, the last new thing that I need to teach you, and this is, if I have time, I'll come back and do these. I want to just make sure I get through what I need to get through tonight. The last new thing, math-wise, that I'm teaching you right now is how to solve what we call double unit conversion problems. A double unit conversion problem means that we have 2 units and we are changing both of the units. Normally, when we have 2 units, we call that a conversion factor, right? So what I'm saying is, I have something that looks like a conversion factor, but it's the given this time, because we are converting both units. The example is this one, 19.3 grams per milliliter. I want us to convert grams to pounds and milliliters to feet cubed. Now, before I do this problem, I want to go big picture for you, because sometimes we get so caught up in the math, you're really not knowing what you're doing. So I want to talk about this for a minute. I live in a world that deals with pounds, ounces, cups, quarts. Most of us deal in that world. If someone says to me, what does 19.3 grams feel like? I'm going to say, I don't know. I don't know what that feels like. If I put 19.3 grams in your hand, do you have any concept of what that would feel like? Most of us would not. Most of us wouldn't. Now, if I gave you a baby, many of you, probably not all of you, but if I gave you a newborn baby, many of you could say, that baby is around 7 or 8 pounds. Now, that's just kind of a knowledgeable thing that most of us know anyway, but most of you would know that that baby doesn't weigh 25 pounds. Most of you would know the baby doesn't weigh 3 pounds. You would have an idea that the baby was that weight. You know what a brown sugar, for instance, the bags of brown sugar at the grocery, that's 2 pounds. White sugar typically comes in a 4-pound bag. So you with me? You have an idea. You know what you weigh. So you have an idea of what things weigh in pounds, but grams we don't. Milliliters, yes, I can use my finger and picture it. So that's not as hard, but I definitely know, like, feet cubed, I can picture foot cubed. So let's talk about this box. These squares on the floor are a foot. These are 1-foot squares. So if I have a 1 foot by 1 foot by 1 foot box, and I said, here, hold this box. If you don't know what's in it, your thinking is, yes, I could hold that, right? It's not that big as far as volume. It's easy to handle. Now the question is going to be, if I filled it with gold, could you hold it? In order to know that, you need to know what it weighs, which is what this is going to tell us. Okay? How do we solve it? We set it up like this. 19.3 grams over 1 milliliter. And we are going to do this all in one problem. We're not going to stop and start. We're going to do this all in one problem. So 19.3 grams to 1 milliliter. I typically deal with the top first, then I'll go to the bottom. So I'm going to deal with grams first. The shortest way is to go straight grams to pounds. You could go grams to kilograms, kilograms to pound. I'm going to go my route, which is what I know, and that's 454 grams in a pound. Does everybody follow me with that?
So we're trying to get grams to pound and milliliters to feet?
Cubed.
Okay. I'm with you now.
Okay? Are we in pounds? Yes. So I'm going to circle that because I don't need to worry about it anymore. It's done. That part's done. But I don't start another problem. I simply ignore this step. I can just cover it up. Don't worry about it for a minute. And now I'm looking at milliliters. So milliliters has to go up on top over here. Do I know anything about milliliters that is equal to something that's cubed? So 1 milliliter is 1 centimeter cubed. Now, my milliliters cancel. Do you see that? Now, am I in centimeter cubed? Yes, but I don't want to be in centimeter cubed. I want to be in feet cubed. We've done this. Now we've done this. So what do I put on top? 2.54 centimeters over 1 inch. But in order to make all this work, what do I do? Cube who? Give me more specifics. I want 2.54 cubed centimeter cubed over 1 inch cubed. And if you need to cube the 1, do it. So, whoops, I canceled that inches cubed. I didn't mean to do that yet. It will cancel. What goes on top now? 12. Go ahead and do the whole thing. 12 cubed, inches cubed over 1 foot cubed. So inches cubed cancels. Now look where I am. Is that what I wanted to be in? So feet cubed is at the bottom. Now I come back and I plug the whole thing in my calculator. Without stopping and starting, plug it in. What do you get on your calculator?
1, 2, 3.777.
Okay. If you did not get that, then let's work on it. Did everyone get that? All right, before we worry about significant digits, I want to look at big picture again. There is a cubic foot box of gold sitting on this table, and you are really thinking that might be worth a little bit of money. Who wants to volunteer to come pick it up? It's worth a lot of money, though. What's the mass of it? About 1,200 pounds. Now, that's not a joke. It really is that. You just did the math. It's right. Guys, there are movies, and James Bond, I think, did some at Fort Knox where they went in and they stole blocks of gold, and they made it, just put one under my arm and run out like a football carry. Don't think so. Don't think so. Think about that. A cubic foot box of gold has a mass of 1,200 pounds. Let me put this in perspective because this is really funny. One time I did a survey, anonymous. Students told me their mass. And the average was about 165 pounds. It would be about 7 or 8, I think. I haven't done this math today. I probably should do that. Let's say 165 times, 165 times 7 is about 1155. Imagine if I just randomly pulled 7 people down here and said they have a mass of about 1,200 pounds. We're going to melt them down and stuff them into a cubic foot box. That's gross, weird, yuck. But the point is gold dense now? Can you now see the density of gold? Yes, a little bit better. Gold is extremely dense. Extremely dense. Okay? Hopefully that helps. Significant figure-wise, this is a great problem for significant figures because this is where we have that scenario of when do I use scientific notation? And the answer is when you have to. Why am I saying that? Some of you haven't got it yet. You can't write this with proper significant figures in normal decimal notation. Go back to the given. How many significant figures does this have? 3. How many significant figures does this have? 3. Doesn't count, doesn't count, doesn't count. This has to have 3. Does a 3 make a 0 go up? No, so we call that 1,200. But if I leave it at 1,200, that is two significant digits. If I put a decimal, that would be 4. So how do I have to write it? Give me exactly. 1.20 times 10 to the third. Come on, keep going, units. Pounds per foot cubed. Yes or no? Does that make sense? All right, let's go to another scenario. I like to drive fast. Unfortunately, they don't like for you to drive fast on the streets. So, there's reasons for that, obviously. The reasons are that when you drive fast, it's harder to stop. Physics, I've had a physics class lately, so I'm familiar with this, and I'm working on it. I've been to traffic school, I really have. Been to traffic school was the best night of my life, honestly. It was so much fun to go to traffic school because I ran into people at traffic school that I haven't seen in years. That was really cool. And so that was fun. Going to traffic school was fun. But I learned at traffic school you can go up to 10 miles per hour over the speed limit, and typically they won't bother you, just so you know. But again, we're all going to try to be safe. Now, on a construction zone, I would really encourage you not to do that because they will double your fine. I have never gotten a ticket in a construction zone. So, but because I like to go fast, I think 45 miles per hour is slow. I mean, to me, that's like, oh my gosh, can we please, let's go, let's go, let's go. So I have to watch it, you know, and so I have to watch it. But is 45 miles per hour really slow? Seems like it to us in a car. How would we know if it's slow? Well, let's figure it out in something that we can imagine a little better. Feet per second. What did I tell you these tiles on the floor are? 1 foot. So, I want us to figure out 45 miles per hour is the same as how many feet per second. So 45 miles per 1 hour. So what does that mean we're doing? We're converting miles to what? Feet, and then hours to seconds. I want you to try it. You try it right now. What is your next step? What goes on top? Over 1 mile. Miles cancel. I want to be in feet. Yes? What goes on top? What goes on bottom? 60 minutes, and then 1 minute, 60 seconds. Yes or no on the setup? I see a lot of folks writing after I write. I'm hoping you guys are getting this. Is it making sense? Question, go ahead. It's still here. I didn't cancel feet. Feet is still here, and that's why I stopped at feet, because that's what I want to be in.
I get confused whenever you have to go like backwards.
Well, I'm not going backwards. I know what you mean. It looks like I'm going backwards. I'm just jumping over that step. It's like checkers. I'm just skipping over that one. I'm now having to deal with hours, so I keep going. But that's why I circled feet, because that's what I need to be in. That's why I didn't worry about it anymore. Once it's circled, that's the end for that top unit. Okay? Practice. All right, what answer do you get? But before you holler out the answer, let's talk about significant figures. What's the only thing that's going to count for significant figures? The given. So what's my final answer? 66 what? Feet per second. 66 feet per second. Yes or no? Okay, now we still really don't know how fast that is, okay? So I'm going to show you. put your foot right there. Thank you. This room is 33 feet, about. You can count the tiles if you don't believe me. I counted them. It's about 33 feet, right? You think I'm going to run. I'm really not going to run. That's what you thought, though, isn't it? Okay, so this room is about 33 feet. Now, how do you count, like seconds? How do you do that? I know y'all know what I'm talking about. One. What do y'all say, Mississippi? Oh, that's funny. I've never heard of Mississippi. I always say 1, 1,000, 2, 1,000, 3. Okay, same thing. That's fine. Y'all say you're Mississippis. Okay. The point being is it very long? No. Okay. So let's start with, just start counting your Mississippis or your thousands, whatever, okay? So go ahead, just start counting. Y'all have to go back. You follow? And I can't run. I mean, I didn't want to fall down for one thing. Or I might pee in my pants or something. That wouldn't be good. The point being, though, I just did 33 feet. 1,000. Doo-doo. You follow? 1,000. Boom, boom. Back and forth. Whew. That's fast. But when I'm doing this, oh, would those people please go? Now, do you realize we drive 80 miles per hour down the interstate? You follow? How fast that is? And you know what you guys are doing? Oh. Yeah. Funny, true story. Last semester, I gave this same little spiel talking about get off your cotton picking phone. The next day, I drove to Glasgow, left Glasgow, needed to get gas in my car, and I have that fancy little app called Gas Buddy, and I'm also a card-carrying Speedway member. So I wanted to see if Speedway in Glasgow was cheaper or if Gas Buddy had somebody else cheaper. So here I had just given this speech. Doing what? Telling students to quit texting and driving. But no, I don't listen to myself. I get on my little phone thinking I'm better than that. I can handle this. You know what I do? I hit the guardrail. It served me right. I still have the slice on the side of my van. And by golly, I was like, you stupid idiot woman. Taught me a lesson. I don't do it anymore. That is how God works in my life. So, my point being, get off your phone. 45 miles per hour is fast. You cannot. Now, here's another true story. This just happened this summer. I actually called a cop out on using his phone while he was in his car. He didn't like it. I was sitting at a stop sign on Campbell Lane going into Scottsville Road. He was in the turn lane, I was in the lane beside him, and I'm with my daughter, and I look over, and he's stopped, but he's on his phone texting. And I looked at him like that. Well, he looked at me, and he was one of those good-looking stud kind of policemen. It was like, he had his tan and all this stuff. He's like looking at me like, what are you trying to tell me? He rolled his window down. And he said, is there something I can help you with? I said, I just thought it was odd that you were on your phone. He's like, it's okay if I'm on my phone. I'm like, okay. I called 911, said, no, I don't have an emergency. I just want to know, is this really right? This doesn't seem right. This bothers me. And here's what I was told. They told me, the cop lady who called me back, because I had to talk to like a sergeant or captain or something, they called me back and she said, I know it doesn't seem like it, she said, but we would much rather you, if you're going to be on your phone, we would much rather you be doing it at a stop sign than while you're driving. So I said, so if I were on my phone at a stop sign, you are not going to get me, you're not going to arrest me. She said, no. And I said, but that's not right, because if the light turns green and you're sitting back here and there's people behind you, that could cause a wreck. She said, well, it's much safer to do it that way than it is driving. I said, okay. So that is a true story. If I see you out on your phone, I'm calling you out, okay? But I'm telling you, quit doing it, okay? Quit doing it. Get off your phone. It can wait. All right. Another scenario here. Another scenario. Swimmers or runners. Do I have any swimmers or runners in here? Former swimmers or runners? Tell me, runner. Tell me give me a number. Speed or not. Or give me what did you run? So okay, did you do swimming? Both? Give me, that would be fine. The reason I want to do it, I want to do a scenario different. Did you run long, or did you swim long course, which is meters? 15 meters. Do you know what your speed was? Woo, she was good. All right, so 50 meters in 27 seconds. Now, that is a number and its unit with another number and its unit. But could that be a conversion factor and then do a double unit conversion problem? You follow what I'm doing? So in other words, we could take 50 meters over 27 seconds and convert meters to centimeters, centimeters to kilometers, kilometers to miles, and then take the seconds into hours, and we could figure out her speed in miles per hour. You follow? So just the reason I wanted to show you that scenario is just because it's not one number with over one like this was and like the other problem was, you can still do a double unit number, a double unit conversion, okay? This problem is not a true double unit conversion problem, but it has a conversion factor in it that's a little weird looking. Similar to what I just talked about. What's the conversion factor in this problem? Did you say it? Somebody's over here saying it. 22.5 gallons in 12 hours. Now, do I need to figure out how many that is per 1 hour? No. Just use that as a conversion factor. Just use that as a conversion factor. Which means then what's the given? 30 days. 30 days. Try it. Try this problem. It is possible to start with a conversion factor, but I'm not going to encourage it. Because at the end, you had to do something else. And if you look at what you did at the end, you left a unit out. And if you put the unit on what you did at the end and shove that back to the beginning, you could get your units to cancel right. So what do you need to get 30 days to? Hours. Are we seeing where to go next? Where do I go next? $22.5 gallons per 12 hours. That's where that goes. Now, finish it out. Does this setup make sense? Make sense or not? What do you get on your calculator? Okay. Significant figures. 30 has a decimal, so that counts as how many? 2. There are exactly, even though there really aren't exactly 24 hours in a day, we call that exactly. We're not going to get into the moon and all that stuff. This is how many? 3, and this really counts for 2 because that is something that is calculated. This doesn't count. This is 3, and this is exact. So what's the fewest? 2. So how could I write the answer? 5,100 liters or liters. Yes or no? Go ahead. Guys, I need you to be quiet. I can't hear her. Divided by 12 times 4 times 946 divided by 10 y to the x3. Now, you could go 30 times 24 times 22.5 times 4 times 946 divided by 12 divided by 10 to the third. I don't do that because I don't want to forget something. That's why I always do it in order. And it's always multiply the top, divide by the bottom. Always. All right, the next problem, I'm going to let you do it. It is just like we've been doing. It's a medical problem. Let you do this one on your own. You're just converting milligrams to grams and deciliter to liter, okay? The last thing, though, before we stop is specific gravity. Specific gravity is something that is used in medicine. Urine, the specific gravity of urine is probably one of the things that you may hear about. You may potentially hear the specific gravity of blood. I personally do not know why they still use specific gravity. Specific gravity is nothing more than a ratio of densities. So, and typically it's the ratio of the density of whatever your substance is divided by the density of water. And if the density of water is 1, then what does specific gravity end up being? Exactly the density, except it doesn't have, say it, units. So I don't know the answer to my own question. My question is, why does the medical world still use specific gravity? Why don't they just use density? I don't know the answer to that, but they don't. But here's what you just simply need to remember is specific gravity is the same as density, except it does not have units. That's it. So on your homework on sapling, if it has a question and it gives you all this information and it says, what is the specific gravity? Then if you can figure out the density, can you figure out the specific gravity? Yes. It's the same thing. Just take off the units. Yes. Okay? Now, before you wrap things up, let's just refresh our memory because I did this at the beginning, so I don't want you to lose things. You are going to print out day 3 and 4. There's 4 pages of notes left. You're going to print all those out. You're going to, if you choose to, listen to me guys, if you choose to, you're going to do the extra credit assignment. That will be turned in at the beginning of class on Wednesday. Your sapling is due, the sapling homework is going to be due next Tuesday night. So make sure that you do that homework before the day of the test because it's due the day before the test, okay? I will see you on Wednesday. If you got any questions, stick around and ask me.